Welcome back to Wonders of Our Planet. Today, we're talking about tardigrades. Most people have never heard of them. Some know them as water bears, tiny eight-legged creatures that live in moss, barely bigger than a speck of dust. But behind that almost comically cute appearance is something that genuinely unsettles scientists. Tardigrades survived all 5 mass extinction events in Earth's history, including the one that wiped out the dinosaurs. They survived open outer space with no protection whatsoever. They tolerate temperatures down to minus 458 degrees Fahrenheit, just 1 degree above absolute zero, and up to 300 degrees on the high end. They absorb radiation over 1,000 times the lethal dose for a human. And they withstand pressures of nearly 87,000 pounds per square inch, 6 times greater than the bottom of the Mariana Trench. None of this is exaggeration. These are published results from NASA and the European Space Agency. What exactly is this animal, and what makes it unkillable? Let's find out. Tardigrades belong to the phylum Tardigrada, Latin for slow walkers. The name fits. A German pastor and naturalist named Johann August Ephraim Goes first described them in 1773, calling them little water bears. Tardigrada sits in an unusual position in the animal kingdom. They're technically related to arthropods but aren't insects or crustaceans. Their closest living relatives are velvet worms, onychophora, and nematodes. A full-grown tardigrade ranges from about 0.004 to 0.06 inches long, small enough to see under a basic school microscope, but not with the naked eye. Over 1,200 species have been identified, and they've been found everywhere. High in the Himalayas, deep on the ocean floor, in the hot springs of Yellowstone, under Antarctic ice, in tropical rainforests, and in the driest deserts on Earth. 1 cubic centimeter of the moss in your own backyard likely contains somewhere between 100 and 1,000 of them right now. Among those 1,200 species, researchers recognize 3 main classes: Eutardigrada, Heterotardigrada, and Mesotardigrada, distinguished by the structure of their outer skin, claw shape, and mouthparts. Some feed on algae by piercing cells with a needle-like stylet. Others hunt nematodes and rotifers, swallowing them whole. A few are parasitic. One species in particular, Rhamnotsodius variornatus, has become the most studied for radiation resistance. Scientists at the University of Tokyo sequenced its genome and found a protein called Dsup, short for damage suppressor. Dsup physically wraps around DNA and shields it from breaking apart under radiation. Researchers have already transferred this protein into human cell cultures in lab conditions, and those cells became roughly twice as resistant to X-ray damage. That experiment was published in 2016, and it's still generating follow-up studies. The mechanism behind all of this is called cryptobiosis, Greek for hidden life. When conditions get bad enough, a tardigrade pulls in all 8 legs, curls into a tight ball called a ton, and drops its metabolic rate to less than 0.01% of normal. In that state, it's technically neither alive nor dead. To survive the drying out, it produces a sugar called trehalose, which replaces the water inside its cells and keeps the cell membranes from collapsing. Water content in the body drops from around 80% down to just 3%. A tardigrade can stay in the ton state for up to 30 years, and then rehydrate back to full activity within hours once water returns. In one well-documented case, scientists revived tardigrades from Antarctic moss that had been sitting in a frozen archive for exactly 30 years. In the ton state, they withstand pressure of 87,000 psi, radiation doses of 570,000 roentgens. The lethal dose for a human is around 500. Temperatures ranging from near absolute zero to 300 degrees Fahrenheit, and the full vacuum of outer space. That last point was tested for real. In 2007, the European Space Agency launched a mission called Photon M3. Containers holding 2 species of tardigrades were attached to the outside of the spacecraft, exposed directly to space. For 10 days, they floated in hard vacuum, cosmic radiation, and ultraviolet light roughly 100 times stronger than what reaches Earth's surface. When the containers were recovered and opened, the majority of the tardigrades came back to life once rehydrated. Some of them reproduced afterward. That was the first confirmed case of any animal surviving open space with zero protection. NASA ran its own follow-up experiments on the International Space Station, and the results held. Tardigrades are currently part of several ongoing ISS research programs. Astrobiologists pay close attention to them for a specific reason. If a tardigrade can survive open space, it could theoretically travel between planets on a meteorite. That's one of the key pieces of evidence behind the panspermia hypothesis, the idea that life spreads across the universe hitching rides on rocks. In 2019, an Israeli lunar lander called Bereshit crashed on the moon. It was carrying thousands of tardigrades in ton state. Whether they survived the impact, nobody knows. But in theory, they might have. The trehalose that tardigrades produce for cryptobiosis is already finding real-world applications. It's being studied for storing vaccines without refrigeration, a major challenge in parts of the developing world where cold supply chains are unreliable. It's an active ingredient in some dry eye drops. The Dsup protein, with its ability to protect DNA from radiation, is being explored as a potential tool in cancer therapy and for protecting astronauts during long-duration deep space missions like a future Mars flight. A research team at the University of Chicago has already synthesized a Dsup analog for experiments in mice. None of this has reached clinical practice yet, but the field is considered one of the most promising directions in biomedical research for the coming decade. The tardigrade tells us something we'd rather not think too hard about. We tend to think of living things as fragile systems that need constant warmth, water, and oxygen to keep going. A 1-millimeter animal quietly proves that wrong by sleeping for 30 years without a drop of water, and then walking away from conditions that would destroy any spacesuit we've ever built. What's strange isn't that tardigrades are exceptional. It's that they're everywhere. In every patch of moss, in every yard, in every country. We've been stepping over one of the most indestructible animals on the planet our entire lives without noticing. If you enjoyed this story, hit the like button and subscribe. That's what keeps these videos coming. Thanks for watching Wonders of Our Planet.